Now we're going to change over to integer subtraction, and we're going to do a lot of the same models that we did for integer addition. We're going to start off with the chip or the charged field model for subtraction. This one's going to be just slightly different than how we did it for addition, because with subtraction, one of the first ways you learn about subtraction is you learn that it's a takeaway type of model. Like if I have 5 apples and you take 3 away, well, I'm left with 2. And so that's something kids learn about, things being taken away. They learn about that really early. So what we're going to be doing here is we're going to be putting some chips down, or some charged little pluses and minuses, and then we're going to be taking some away. So whenever you see the subtraction sign, you want to think the word take away. And this involves, we might have to add some stuff in. We'll talk about here some things called zero pairs. I'll explain as we go. So on the first one, it's 2 minus 4. So you see this 2 is positive, the 4 is positive. So we're going to read that 2 take away 4. And everything is positive in this model. So I'm going to put in 2. That's what we have to start with. There's 2. And I'm supposed to take away 4. Well, the problem is I can't take away 4. I only have 2. So how am I going to get more stuff in there without disrupting the balance of the circle? The circle needs to be equal to 2. Well, you can add what are called zero pairs. So a zero pair is when you add in a plus and a minus at the same time, because that net value there would be 0. So we're technically adding nothing. This is like a sneaky way to get in there what you need. So I need to have 4 pluses that I can take away. And right now I only have 2. So I'm going to add a zero pair. I'm going to do it like this. So this is my little zero pair that I'm adding in. So technically, if these are each 0, I still have only 2 represented on this picture. So I added in some sneaky little zero pairs. So then you go, okay, well now, can you take away 4? And you're like, oh yeah, now I can take away 4. So I'm going to take my 4 positives. And if you're going to do a takeaway model, you have to actually do this part. You have to show this part where those are being taken away. And if I take those 4 pluses, those 4 positives out of the picture, what's left behind? 2 negatives. That's what's left over once you add in some zero pairs. So on this one, we're going to add in 2 zero pairs. That's what we had to add to this one in order to have enough positives to actually physically take away. I know this seems strange, okay, but give it a chance. The next one is 5 minus negative 3, and you see there's a double negative in there. Okay, so what this says in words is 5 take away negative 3. So the first thing I'm going to do is I'm going to put in 5. There's 5. And I'm supposed to take away 3 negatives, but I don't have any negatives. So how am I going to get negatives, sneaky negatives that I don't have? Well, I'm going to add in some zero pairs. I need to take away 3 negatives, so I need to put in 3 zero pairs. So there's my zero pairs I just put in there. And what I'm going to take away is negative 3. So these 3 negatives, I shouldn't have drawn them so close to the positives. Those are going to get taken away. And if we take away those 3 negatives, you can see what's left is a bunch of positives. How many positives? 8. And this explains why the answer is 8, right? 8 positives left over. I'll say that. That's a terrible way to write that. 8 positives, pluses left over. A lot of you were taught to just change the double negative to a plus, and that's fine. We're going to talk about that later. But this explains why you get a positive answer. So we had to add in 3 zero pairs so that we would have 3 negatives we could take away. Let's try a couple more. Negative 5 take away 3. So negative 5, take away 3. We're not taking away 3 negatives, we're taking away 3 positives. And so you look at the picture and you're like, I don't see any positives. Yeah, I know. So we're going to put some sneaky 0 pairs in there. I'm going to put 3 of them in there. So add in 3 0 pairs. So here's my negative 5. And now I'm going to take away 3. And what's nice about this is if you can imagine those being taken away, you can see that everything left is negative. And there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 negatives left. This is a really good one for explaining why the answer is negative, because a lot of times students will say that the answer is like 2 or negative 2. And so they're just looking at the 5 and the 3 and not considering the signs. So on this one we added 3 0 pairs. And what was left was negative 8 left over once we take away the 3 positives. All right, one more. Negative 4, take away negative 3. Negative 4, and I'm going to take away 3 negatives. Well, lucky for us, we already have everything we need. We don't have to add any 0 pairs here. There's negative 4. I'm going to take away negative 3. And you should be able to see what the answer is. What's left behind? Just this one little negative. So negative 1 left over. So your answer will be negative 1. Don't have to add any 0 pairs on this particular example. So that is the chip or the charged field model for subtraction. It is a little strange. I don't know if this is something you would want to teach, whether you think that the elementary kids could do it or not, or maybe this would be middle school. This would probably be like closer 5th, 6th grade, 7th grade when they do the negatives, when they really get into those. But anyway, it's a possibility. It's an option that you've got in your tool bag.